Good afternoon, everyone. It's my pleasure to introduce Professor Varsha Ajit Shah. Professor Varsha Ajit Shah, a senior faculty member in the Department of Electrical Engineering at Sardar Vallabhbhai National Institute of Technology, SVNIT, Surat, with over 3 decades of teaching and research experience. She is a recognized expert in electric vehicles, hybrid energy systems, electric drives, and power systems, and has been with SVNIT since 1987. She has supervised numerous PhD and MTech students, contributed extensively to international journals and conferences, and is actively involved in research, consultancy, and curriculum development. Professor Shah also led key projects such as electrification assessment for Surat Municipal Corporation in collaboration with US Department of Energy, and holds patents in the area of EV technologies. She has delivered expert lectures across India and served in several academic and administrative roles at SVNIT. Now I kindly request Dr. M.M. Lokande sir to offer a sampling book for our honorable guest speaker, Professor Varsha Ajit.
SVNIT touch to this part. Director is from SVNIT, sir also from SVNIT. I work in SVNIT. Professor Abdul Bandari also was there, mechanical.
Whichever you like. मुझे कुछ नहीं, इसकी तो मुझे आदत नहीं है। नहीं तो ये लगा दो, चलो आपको जो ठीक लग रहा है ना वही करिए। कहाँ बोला इसमें? Okay. Of course, today my topic is little bit different. You might not be not exactly related with the topic on which this workshop, or you can say the short-term course, has been organized, but still it is related with this part, but that is related with the electrical vehicle charging. So here I am just discussing about overview of energy storage technologies for electrical vehicle charging station. All of you are aware that we are just in a era of implementation of EV, or transition from normal, or you can say the conventional vehicle sector or transportation sector to electrified transportation sector. But when we have this electrical vehicle, they required a power. And we all know that the power is, if that electrification is through the existing power supply line, in that case, the vehicle will get power through that. And all of you are aware that our trains are working with this. But when we talk about the road vehicles, in that particular case, the road vehicles will be always equipped with an energy storage device. And this device is our rechargeable device, because after certain use they get exhaust and we have to again recharge it for the next operation. So we need to charge this electrical battery with which your vehicle is equipped. So whenever you would like to charge it, we have to select the option that from where we can charge it. And we have the only one option today, looking to the today's scenario, that is our electric grid. And still we are moving towards renewable energy sources also, which has been integrated with the electric grid, existing grid, but still the option is only with electric grid. Then how we will interface or connect this EV with the existing grid, and what should be the impact on that grid, and how to reduce that impact, or how to find out its mitigation. Talk about electrical vehicle, they are interpreted as a zero emission vehicle. Anyone can answer, what do you mean by zero emission vehicle? But under what condition? Yeah. No, no, it's not like that. When we talk about zero emission, it means that, as I have told you, that we have to charge the vehicle. From where we are charging? Grid. Grid is also contributing to the emission. So in that case, we can't say that our electrical vehicle is a zero emitting vehicle. Yes, we can define like that. When it is operated on road, it doesn't emit any emission. And that's why it is interpreted as a tailpipe emission. So there is no tailpipe emission. But as the charging is through the conventional grid, it always again contribute to the emission. So if we will go with the solution of, you can say, the renewable sources, then again we are moving towards a zero emitted vehicles. Even if you look at the today's scenario, Prime Minister Modi have again declared another cell in which they are now trying to convert all trucks which are running on road, on a freight road, or suppose might be with some other applications. They would like to convert it into an electrical vehicle. Of course, a percentage of that trucks are hardly 3%. But we all know that it is a diesel operated vehicles, and they have to work with a very high amount of load, and that's why they contribute more to the emission. Of course, 33% of the emission will be from this type of vehicle. So if you look at this, the concept, or you can say transition to electrical vehicle is the, you can say, today's need. But when we do this, we have to charge battery from a grid, and that will create impact on a grid. And that impact I have mentioned in this way, that a peak demand. The peak demand, it means that we may connect our vehicle at any time on a grid. But we all know that if you will observe the demand curve, daily demand curve of any grid, then you will observe that somewhere we will have the low demand of power, and during certain periods we have peak demand of power. So if we do the charging of this vehicle under any conditions, then definitely it will create impact on a grid. Second point, that is related with the voltage fluctuation. So there is a voltage fluctuations because of connection of this electrical vehicle to the grid, and that will again lead to an instability in the grid. So to mitigate this thing, we can go with proper planning and smart charging strategies. All of you are aware of this. What do you mean by charging strategy? Little bit about timing. What do you mean by timing to charge the vehicle, right? So that again depends on your load demand response. Based on that, you can have time of charging, or that slots are available and will be interpreted in terms of a coordinated charging. We may interpret that in terms of the coordinated charging. In the next few slides, I will show you that also. So you need to have a smart charging strategy. But here this charging strategy will have two different meaning. If it is with the grid, the things will be different. How we are charging it means under what scenario we are connecting this EV with the grid. And second part with the charging strategy is how we are charging our battery the control algorithm which we are using to charge our battery. These two things are totally different. And this charging strategy, I think somebody have asked question in the morning that BMS will provide the reference current of charging for any kind of battery whenever we are putting it to a grid for a charging. Then the impact can get mitigated through this, and even the beneficial for the grid stability. And we may go with the renewable energy integration also. And the most important part, that EV can be contributed to more resilient and sustainable energy system. So like we say the renewable energy system as a distributed source of energy. Similar way, we can treat EV as a distributed source of energy. It means that this EV will act as a load also for the grid and source also for the grid. So we will get, you can say, another support. Even that means we have some, you can say, it requires a charge power, that is one thing, and it helps the grid. Two-way, so impact may be a negative impact while charging without any condition. And second thing is, when the grid is operating in a peak load conditions, and if the grid is not able to supply that amount of grid, this EV battery can use for supplying active power. So with this, let us see that what are the negative impacts of this EV charging on a grid. One is increased peak demand, that's what I have already told you. Second point is a voltage fluctuations. Large scale EV charging can cause a voltage drop or the surges in the grid, especially in area with the limited grid capacity or at the end of distribution line. Third point is grid congestion. So connected charging patterns can lead to a grid congestion in specific area, potentially limited to the capacity of grid to deliver power to the other users. Because when we are connecting this EV with a grid, it doesn't mean that only EV is only acting as a load on the grid. Other consumers are there and they always require a good quality of power. Harmonic distortion. Usually the EV chargers can contribute to this harmonic distortion, or they inject harmonics in the grid. And usually in India, most of the chargers, they are not specifically, especially for the two-wheeler and three-wheeler, that chargers are not specifically designed to meet with the criteria of a grid. That means when through that charger, when we charge a battery, they inject harmonics in a system. And all of you are aware of that. What is the effect of harmonics? Harmonic currents are there, it generates a heat, right? I square R losses will be more. Which has a negative effect on a lifespan of electrical equipment also. And all these points will ultimately interpreted in terms of power quality. So it reduces the power quality. So overall, increased EV charging can lead to a decline in power quality, causing instability and inefficiency in the electrical system. So these are the negative impacts. Let us see the positive impact. Positive impacts, and we'll look at the mitigation strategy also. So the first is a smart charging. Today's we are always talking in terms of everything to be a smart, right? Everywhere we are adding these words smart. Grid, we say that the smart grid. It means that the grid is a control grid providing so many features to do almost all tasks automatically. So our grid is a smart grid because that grid will have a capability to allow you to integrate all non-conventional sources also. So we have a smart grid, and with the help of that smart grid, the smart charging is possible. So implementing smart charging system can help. So this is nothing but your mitigation technique, that our charger must be a smart charger, and which can help manage EV charging load by shifting charging to off-peak hours, reducing peak demand, and optimizing the use of renewable energy sources. So everything is possible. These are basically these 2 points. One is a shifting of charging to a off-peak period, and second thing which I have told you, that it can be like you can shift the load, that is one point, or you can allow the additional sources which will help the grid to mitigate the impact on a grid because of EV. Second point is grid aware charging. Integrating EV charging with the grid management system allows for dynamic charging adjustment based on the grid condition, optimizing grid stability, and it allows you to prevent overload condition. Second point, which I have already told you, that is interpreted as a vehicle to grid. As I have told you that the EV system will act as a source as well as load. So when we talk about V2G and G2V, V2G means we are able to transmit power from vehicle to grid, and G2V means we are able to transmit power from grid to vehicle. So it is a bidirectional way of power flow that is possible only with this EV application. And to mitigate it, again, we have to upgrade our infrastructures. As I have told you that if we'll go with the e-truck, can you imagine that what should be the power requirement to charge the e-battery of a truck, the battery of a truck, e-truck? Anyone can guess? Because these trucks have the weight more than 3.2 tons, even more than that. Anyone can guess about it? No, no. It's a very small amount. It is in terms of megawatt. And that can be again interpreted in terms of fast charging. Usually everyone wants that. Nobody have that patience to wait for 4 hours, 5 hours to charge your battery, isn't it? So if you go with the fast charging concept, that within 30 minutes or within 1 hour you would like to charge your battery, then definitely the power peaks will be there. Right? So if suppose the e-trucks will come in picture, we need to charge them. So very high amount of power is required, and that is in terms of megawatt. Of course, on that, when we talk about this or whatever I am discussing just now, basically it is divided in 2 parts. The one part that is related with the vehicle itself, and second part is related with the existing power network. 2 things are there, and we have to manage both the things. And last point, time of use pricing. Time of use pricing is nothing but basically in a low demand period, if we'll charge our vehicle, the rates are very low, and during peak period, the rates are very high. But when we do that, we are again affecting the grid performance. So it is always avoided. So now I have not mentioned anything about the energy storage device in the previous slide. But one of the solution to this, to support the grid functionality by putting your EV on a grid charging, is the energy storage technologies. Additional energy storage device that we need to put on every charging station, and that will support the grid performance. So energy storage technologies will play a very crucial role in electrical vehicle charging station by enabling faster charging speed. That means we can charge at higher speed because we have the additional source available with us, so which will not put any impact on a grid. Then mitigating the grid stress and facilitating the integration of renewable energy sources. Why this? How it will facilitate the integration of renewable sources? How this energy storage device will facilitate integration of energy storage device? Yes, right. Because these renewable sources are intermittent in nature, We cannot predict that how much voltage current that they can supply at any time period for which that renewable sources are available. So they are all intermittent in nature, and to balance out the power requirement with respect to renewable sources, the energy storage device will play a very important role. So, and again, it will help to optimize the energy use also, and promising return on investment, ROI. How you can interpret this return on investment? So you have to listen to me without any stress, right? It's very in general I am discussing. So no burden on you. How it can promise us to return on investment, ROI? Providing, yes. This ROI is with respect to both consumer also and the provider also. And that is what I have told you, that the shifting of your charging of EV in a different part of your demand profile.
According to the prices of the...
Yes, according to the prices of that. And if we have the energy storage device, they provide that help. Let's say we have the solar energy system. It is providing power, but many times that happens that it is a daytime and very few vehicles are available on the charging station, and whatever power that has been generated by your solar panels are more than the charging power requirement. So where it goes? Then if we have this type of energy storage device, we are dumping that power in that. And when the grid is working in a peak condition, that time again the solar power is not available, right? So it will support the grid also. So that way you will have the multifunctionality of this energy storage device as far as the integration of EV with existing grid, including all renewable sources. And common technologies includes battery energy storage system, which is a very proven technology. Of course, we have started the old type of battery is a lead acid battery, and then we have moved to the lithium ion battery, sodium ion battery, and even we are moving with the solid state battery also. And they have a good energy density and power density. So that battery energy storage system, the another device known as the ultra capacitor. Have you heard the name of ultra capacitor? What is the difference between battery and ultra capacitor? Those who have heard about it?
Fast charging.
Yes, fast charging, discharging.
Life cycle is more.
Yes. Yes, then? Supercapacitor will have a very high power density, but its energy density is low. So we have the two opposite characteristic sources are available in market. Battery, high energy density, low power density, and supercapacitor, high power density, low energy density. And if you will look at the vehicle power requirement is both high power, high energy. How you can justify this? Can you give me some example for that? That is what we call, that's why the energy. It's energy. Long term is energy, short term is power. No, that's why I have just given you an example that combination of these two sources is the most favorable source for EV application. EV, to run a EV on a road. Yeah, that's what I have told you. But the reason behind this, can you give me some example? Then only this is a valid reason or valid solution that we go with the hybridization. That is okay, but how you justify this? Justification is also needed. As I have told you, one is the high power density, means it provides a peak power. Second is a high energy density, it will provide a power for a long period of time. But then why the battery itself can do that task? Just now it is doing. No, forget about just now charging. We come to charging later on. Okay, I am giving you one example. A very old car, Maruti 800. What should be the size of engine? 37 HP. I know that. 37 HP. So that 37 HP is a very high power of the engine. Do the vehicle require this much amount of power? It hardly required between 5 to 10 HP, not more than that when it is running on a road. But when you want to start it, the acceleration power requirement is very, very high. So a single source, that is another reason why your engine will have a very low efficiency. Because we are not running our engine with its full capacity. Only for a short period of time, we need its full capacity, but for the rest of the time, we need only 5 to 10 HP power. And the size is 40 HP, near to 40 HP. It means that if we will work with a single source, then definitely the overall efficiency of your system greatly reduces. Because we are not, suppose I am using a battery, the full capacity of battery is not used continuously when your vehicle is running on a road. Does it? Because acceleration power is 10 times higher than the normal power requirement. So we are not able to utilize full capacity of that single source. And that's why this solution is a preferable solution if we have the characteristic of a source is which will meet with the vehicle power requirement. Right, now come to the charging. Okay, tell me. Actually, for this particular grid application, as I have told you that the grid might be requiring a peak load for a short period of time, that duration is not too long. So in that case, instead of taking, as I have told you that these are the energy storage devices which we can integrate with the grid. So if I have supercapacitor also and battery also, which unit I will select to get the power to support the grid requirement? Supercapacitor or battery? Supercapacitor. Because it is for a short period of time. You can take power from supercapacitor. So if we have supercapacitor and battery both, then of course the system becomes very complex because you have to select, as per your requirement, you have to select the different sources. That way the system becomes complex. But it provides a better solution to the system. And when the grid is demanding a long duration or low level of power, it can be supplied by battery. So transient, it can be interpreted like a transient and steady state condition. So supercapacitor application with the transient mode of operation and battery will be with the steady state mode operation. That's true with the vehicle application also and during charging application also. So this way we can say that battery supercapacitor are a viable source which we can use it either with the vehicle functionality or for a charging also. And the second option, it is not an energy storage device, but it is a fuel cell. right? Fuel cell, we can't say that it is an energy storage device, and usually it is a unidirectional. It generates electricity and support the power. So how this fuel cell is working? We are not going in detail, only a very basic, that is, I'm not going in the internal part of that, the characteristic. Will it start immediately? The engine, you are knowing about the our IC engine. Will it start immediately? No, it takes time. Right? Similar way, the fuel cell will also take some time to develop its rated voltage. And that's why this fuel cell are always provided with the energy storage device as a supportive device to start the functionality initially. But fuel cell is again a viable option unless and until we go with what type of hydrogen? We are using a word green hydrogen. What do you mean by green hydrogen? It's a hydrogen, fuel cell, hydrogen based fuel cell. But I'm putting ahead of that a name green. What do you mean by green hydrogen? Yes, when it is produced by renewable energy source, we call it as a green. And in that case, again, we are moving towards zero emission path. So many companies are now in the field of producing this hydrogen based, that is a fuel cell using hydrogen, which is green in nature. And as far as the battery storage device is concerned, the main technology today in the market is a lithium-ion battery. But this lithium-ion batteries, again, will have the different chemistry for the lithium-ion battery. And based on their chemistry, their characteristic will also change. But in short, different chemistry of lithium-ion batteries are available in market, which you can use for this purpose. You can see that the commercialization of on-road electrical vehicles faces multiple challenges, such as an adequate number of charging station availability, charging time, and range anxiety. So the first part is number of charging station availability. So as per the government mandate, they have declared, I think that part I might have not included over here, but they have included the new policy for this e-vehicles, that is for the charging infrastructure. And on a highway and even in a city, they have to provide, within a certain interval of distance, they have to provide a charging station. And especially on the highway on both the sides, every 25 kilometers, they have to build a charging station. And even in city, but in city again, they have to see the map of city and availability. Accordingly, they have to provide a charging station. But how to find the location of this? It's very important. And there is no mandate for, government mandate for going for establishing a charging station. You don't have to take any permission, but you have to only follow the norms to build a charging station. Anyone can go for that. But how I will find the appropriate location of charging station? That is again a very important thing. How will determine? Then we interpret like a footfall of the vehicles. That is one thing, right? Second thing, availability of power also. Third point, that is related to the integration of RE, that is renewable energy sources. Anything else which is a very important part? Because as I have told you that the availability of power, how will determine availability of power? Or the because availability is again related with the requirement of power to charge that vehicle. Anyone can answer? The amount of power at charging station to charge the vehicle. Average and peaks both are different. Fine. But still something is missing. Huh? We assume that we are getting power continuously. But the amount of power that we need to charge the vehicle, does it constant? So it depends on what? It depends, because say, suppose one vehicle is coming for a charging, it requires hardly a 5 kilowatt of power. Second is coming, which requires 20 kilowatt, 50 kilowatt power. How you can interpret that? And that is based on the SOC level of the battery, which is coming for charging. So you have to again go for interpretation of that power level or the charging power level based on some averaging mode, that what should be the minimum charge of your battery and what should be the maximum charge of your battery. Again, it depends on what type of battery that your charging station will allow to charge. And for that, we have different types of connectors. So whether that connection is available at that charging station, that is also very much required. Then how we'll find where to go for a charging? It is okay, so power can be calculated based on this. We have to choose a span of a battery SOC and with some averaging value of the battery capacity in terms of ampere hour or in terms of the kWh. Now how I will find an appropriate charging station for charging my vehicle? No, that is okay. So we know about it. No, this is needed by the charging station. Now as a user, I would like to charge my vehicle. How I will get the appropriate charging station where the charger point is available for charging? Yes, based on AI applications. So you have to, you may have the applications, and based on that applications, you can find out the nearest charging station, and then whether the terminal is free for charging and whether the type of battery, whatever you have, whether it is supporting it or not. Everything you can find out through that app. Okay. Now, issue of charging time, which I already told you, which will be interpreted in terms of the coordinated and uncoordinated charging. I will show you in the another slide something about that. Range anxiety is the most important thing for everyone. And that is the reason why the people have moved for the, you can say, the more use of electrical vehicle is totally based on this range anxiety. How much range? So how we can solve this? Range anxiety means there are multiple options also available for this with the configuration of your vehicle. So how you can reach to that range anxiety solution? So the very simple solution is a higher rating of a battery. In single charge, it can travel more kilometers. But that is not the viable solution. The simple solution is a fast charging. Simple solution is fast charging, but it doesn't mean that you are charging your battery to a full level. Full level means 100% SOC. No. And that's why this methodology will be basically interpreted as range extension. Suppose your battery is reached to a 50% and now you are finding some charging station. You can wait for half an hour, right? So within half an hour it gets charged to 80%, not more than that. So the range extension has been available. So fast charging concept is the solution with the range anxiety for a people, those who doesn't have any patience for waiting. And the energy storage system, additional energy storage system. Here I have given you a very simple way that let's say some problem will be there with the grid goes down, EV charger will also goes down. You cannot charge your vehicles with the required amount of current because the availability power will be less. And if you will have the energy storage system along with your grid, then even if the grid will have some problem, you can charge your vehicle. It will support the grid functionality. So I think this I have already told you, the need for energy storage system in EV charging station, grid stability and reliability. Yes, this is the most important part. That is the need for energy storage system in charging station with managing two-way of your power flow. And one is a load shifting and other is a peak saving. I have shown two graphs. The first graph that is with the load shifting and second graph is with the peak saving. And I have already told you, just read it. It's a very... Load shifting means we are rescheduling the charging of EV. Rescheduling means we have to see the generation profile and the load demand profile, and accordingly whenever the demand will be low and generation is high, you can charge your vehicle. So this will be interpreted in terms of the coordinated charging. We are coordinating the charging of EV. That is what we call it as a load shifting. And while peak saving focus on reducing power consumption during peak hours by utilizing on-state energy storage or by any other method, you can charge your vehicle. So that again, we are not putting any stress on a grid. So this two-way, we can manage the power distribution from a grid for charging our EV. Then I have given you a solution, renewable energy generation, integration, fast and ultra fast charging. That also I have already discussed. What do you mean by ultra fast charging? I think today sir said something about that, ultra fast charging. Yeah, 15 minutes, not exactly the 5 minutes, but within the range of 10 to 15 minutes. And Tesla has provided this fast, ultra fast charger is available with this. But of course, you have to always check with your battery, whether your battery is able to charge at that rate. How you determine the charging rate of battery? It is always interpreted in terms of C rate. Battery C rate means if I am having a 10 ampere hour battery, the 1 C rate is nothing but corresponding to the battery can continuously provide power in a 1 hour corresponding to 10 ampere. That is ideally speaking, not truly speaking. Otherwise, you can say true condition is lesser than this, because we know that the certain amount of losses are always there in a system. So that way also you can have, you can say the 10C rate. Can I go up to 10C rate? 10C rate means 10 ampere hour battery I can charge at 100 ampere. And in 0.5C rate means I am charging my battery at 10 by 2. 10 by 0.5 means 10 by 2. Which is allowable. Definitely. You are right. But the design of, or you can say at the time of manufacturing, they have designed the electrodes and electrolytes of a battery in such a manner that they can withstand at least certain C rate. At least I have heard about 6C rate. But we have to always see the data sheet of battery, which are provided by the manufacturer. If they have mentioned that you can charge at 6C rate, you can charge it. It is the most preferable mode for battery charging. You are 100% right. No, not like that. Exactly not like that. It depends on the battery chemistry and the charging capability of a battery. But truly speaking, definitely it will affect the battery chemistry. The performance of the battery will get affected. But when the manufacturer says that you can charge your battery at 6C rate, 2C rate, you can charge it because they are providing a warranty or a guarantee till either 8 years or 1,80,000 kilometers. In between, if anything happens wrong, they will replace it. Based on that only they have designed a fast charger. Otherwise, why should they go for fast charging? If it is the main, can say, if with the fast charging, if we are not able to protect the battery functionality, no one will allow us to charge the battery at that rate. And this ultra fast charging, I think only Tesla is providing just now. And they have built their separate connector also for ultra fast charging, and that will be implemented within 15 minutes time. Even with the fast charging, you can interpret like how much amount of power that it needs. I am having 100 ampere hour battery. I would like to charge at 3C rate, 300 ampere current. Immediately we are drawing from our existing power source with the required level of voltage level of a battery. And usually it is available nowadays. Even in car, they are using 400 volt battery. And the secondary battery network, they have changed from 12 volt to 48 volt. So very huge amount of power that has been demanded by the, and again it depends on how many number of terminals are there and at a time how many number of vehicles are connected with that. So it may be, it may generate overloading conditions for grid also. So in that case, if we have the ESS, energy storage system, it will provide the support. Everything I think I have return on investment, cost saving, that also it is again related with how you are charging, at what rate you are charging. That is a shifting of your load in terms of the coordinated charging, which usually defined in terms of one-time use tariff. That is a low tariff condition. Revenue generation, how you can interpret this as a revenue generation. So charging station is a separate part. Charging station is getting power from a grid. And charging station is equipped with your energy storage device. So how it will generate a revenue? I also mentioned over here. Voltage regulation. For voltage regulations, you won't get anything. Why? Why we are not getting the battery? Battery is not providing any voltage regulation, but battery is always equipped with a power electronics device. And then that power electronics device will support the reactive power demand of the grid. Because the reactive power, sir, am I right? The reactive power is related with the voltage fluctuation. So the converter will provide that reactive power compensation. So even the consumer is ready to provide that facility to the grid. But the real power supply facility, will the consumer is ready for that? If suppose it is with the existing only EV as a load, working in a bidirectional mode. If your car is there, you are the owner of your car, battery owner, you are the owner of battery, would you allow the grid to take power from real power, I'm talking about real power, active power from a battery. Consent of consumer is needed. Why? Because it is related with the charging and discharging cycle of your battery. So unless and until the, you can say the amount, additional amount that has been paid by your grid is matching with the, actually the cost of your battery along with its life cycle, then the consumer will allow it. But on a charging station, when we are putting an additional energy storage device, then definitely if they are agreeing or they have some agreement with the grid, and if they provide real power, then definitely they will generate a revenue from that. So it is charging station owners will get that revenue through their ancillary services to the grid. Second is increased consumer satisfaction, because fast charging is possible. The power is also available even under any grid operating conditions. So consumer will get satisfied with that. And future proofing infrastructure. If the demand is increasing, this will again help to match with that demand. Another point that is related with the environmental stability. Leveraging renewable energy sources and reducing reliance on the fossil fuel, ESS contribute to environmental sustainability also. This promotes the transition to a cleaner, greener transportation ecosystem, aligning with substantially global and regulatory requirement. So let us focus on a few very simple terminology with the charging. That what are the different charging methods for charging your electrical vehicle? There are basically the two ways by which you can charge it. One is a conductive charging and second one is wireless charging. And in between I have shown the battery swapping. So what do you mean by battery swapping? Is it a very easiest way? Swap means change the battery. What benefit we can get if we'll go with the swapping of battery? Yeah, only time? But when we go with the swapping of battery, it's a very difficult task. Is it an easy task? My own battery is there. How can I allow them to take my battery and I will take their battery? We don't know its chemistry, its status, right? It's very difficult. So what is the other option for that? Anyone can answer? Because it is again related with the revenue, or we can say the money. That is not the concept of battery swapping. Swapping means replacement of the battery. Yes, definitely. Okay, so usually the consumer won't ready to go for battery swapping. But what are the other options in which consumer can go for battery swapping? That I am asking. Okay. But what is the other solution? Other solution is I am the owner of only vehicle, not the owner of battery. Are you getting it? The battery owner is the battery provider, where you can do the swapping operation. In that case, we can do that. That option is available. And again, the battery swapping is not an easy task. How the battery has been placed in your vehicle, how to remove it and how to put the new battery and how much time it will take. If it is a task of only 5 minutes, then it is okay, like a filling of the petrol in a tank. But I don't think that it again depends on the constructions, or they have to reconstruct their vehicle in such a manner that they can go with the battery swapping concept. Otherwise, we have conducting charging and wireless charging. Two options are available. But as in the morning, sir said that wireless charging will be with the low power requirement, and conductive charging you can go for any level of power, where you will have the onboard charger, off-board charger. This is related with the vehicle. So vehicle with the low rating, the charger is available within the vehicle, and if it is of a high rating battery, then the charger is external to the vehicle. And there again it becomes very difficult to establish communication between the battery management system of the user along with the charging station. And then if it is a wireless charging, you have the capacitive, inductive and resonance conductive. There are so many other options available with this wireless charging. It's the same thing, but the difference which I have shown over here is power supply, either AC/DC, or the power flow may be unidirectional or bidirectional with the charger. And these are the different types of chargers available with their ratings, and their names has been mentioned over here. That this has been discussed in your class previously. I have mentioned with the Bharat standard. Two standards are with the Bharat, three I think, that is level 2, level 1. And level 3 will be with the type 2 also, as well as different international charging connectors, CHEDEMO, CCS1, CCS2, and there are other options are available. क्लास देख लेती हूँ क्या है. And this is again the only a diagram with, I think all of you might have seen this diagram many times on a net also available. What should be the capability of fast DC charger power level? Here I think I have mentioned as 240 kilowatt. It is even today's, it is more than that. It has crossed up to above 350 plus, 350 kilowatt plus. And this one of another things which I would like to show it to you is a battery integrated EV charger. As I have told you that we have a separate battery that we are interfacing with the existing grid. Now we have the battery charger, external battery charger. This is what I am talking is the external battery chargers, which is available in market with this rating 60 to 80 kilowatt plus and plus 42.5 kWh rating, which is available in market. It has an inbuilt battery. So you don't have to connect the separate battery for that, for the support of the grid and for charging your vehicle. And these are the ratings which I have mentioned, and you can see that the output voltage range is 150 volt DC to 1000 volt DC. I think this voltage range for the other DC chargers without battery, inbuilt battery, it has even more than 1000 volt, 1200 volt level. And they use CCS2 connector. And it is provided with all protections which I have mentioned here. And battery capacity is 60 kilowatt to 80 kilowatt, depending on 60-80 kilowatt type of and it looks like this. So here I am terminating my presentation. Thank you for listening me patiently. If anybody have any question, you can ask. One minute. इसको बंद.
Thank you, ma'am. We truly appreciate your time and the valuable knowledge you have shared with us today. Now I request Dr. P.S. Kulkarni, sir, to present the certificate and book to the Professor Varsha, ma'am.
So last session by Professor Putta sir. Hope you have got the feedback forms. Please fill that. We will collect it after the session. Microphone.
Okay, we can start. Okay, thank you. We have been discussing a few things, and this is where I wanted to end up with. So there are many things we need to do with power systems. Now the new thing is that we have got a power system, or we very soon have. I'm sure that in India also there are a lot of inverter interfaced or inverter based generation. So in the conventional or the power system today, how do we make sure that our system is healthy or it is normal? What are the indicators that our system is normal? How do we find that out? What do we do to keep an idea or keep a monitor if the system is healthy or not? How do we do that now? Voltage and frequency. So we do voltage and frequency. So now the question is, can we do the same thing for this grid? Can we do the same thing for this grid? That's the question. Okay, which are they? Okay, so first let us look at that. What will voltage tell us? If I monitor the voltage in this grid, what will it tell us? What will it tell us? If I am monitoring the voltage in a grid, if I have got 10 inverters connected, I am supplying a, let's say VNIT campus I am supplying, I monitor the voltage here, what can I pick up? Power factor, okay, power factor, reactive power, and any other? Demand and generation, okay, very good. Okay, so presently in the grid, what tells us about demand and generation? Right now, somebody is monitoring the grid so that we have got a stable system here. What is it that tells us about if the demand and generation are matched or not? Pardon? What is it in this grid right now, the way it is operating? How do we know that demand and generation are met? अरे इतना बड़ा झंझट किया था अभी घंटे पहले. How do we make sure that the demand and generation are met today, right now, at this instant? अरे इतना बड़ा झंझट हुआ यार, क्या मतलब? You said sir frequency और वो सब आपका हो गया लंच के बाद. मरवा दिया यार. 5वें दिन के अंत में आप कह रहे, I mean, we had so much discussion on that, right? Or did we not? That how frequency is monitored. If there is a change in the load, the generator speeds will change, that will change the frequency on this and that and all that. अरे यार उसके बिगर how can anybody live in power system industry without understanding those things? They are so fundamental. मैं इतनी सारी चीजें इतने चीख के कह रहा हूं because I cannot imagine any academic environment where people can live without mastering these things. I cannot imagine. बाकी तो सब कहाँ गया सब all right है. But the fundamental principles, you cannot do anything. If you are doing something, believe me, you are not doing it to your efficiency. अब somehow चल रहा है काम. अपने को somehow काम नहीं चलाना. ठीक ठाक काम चलाना है. So frequency was monitored to make sure that the load and demand are matched. Right? So how in the new system, voltage will tell me that what demand and generation are met. Or in other words, is there a way in the new system? That's the whole crux of what I have to talk, whatever little time I have got. How would you make sure that demand and generation are matched? Unless the problem is clear to you, how would you give a solution? I mean, that's very fundamental. Such a big system operating, are you not wondering how the hell it is all coming together? कैसे ये चल रहा है? That's a very basic curiosity that should drive you. That how is this all big system running together? And you are all studying to transform the new grid. उसको ट्रांसफॉर्म करना है तो उसको पहले चलाना तो पड़ेगा ना. So to run that new grid, how would you make sure that the load and demand are balanced? Or load and generation are balanced? होना चाहिए ना आइडिया. रिएक्टिव पावर बैलेंस, ओके, तो आपने कहा वोल्टेज मेजर करने से रिएक्टिव पावर बैलेंस आ जाएगा. आपके पास 4 इन्वर्टर आपने लगा रखे हैं. देयर इज अ लोड देयर. दैट लोड चेंजेस. हाउ वुड यू नो to change, how would you know to change your device operations to match the load and generation? कोई तरीका है? Okay, so what can you say about frequency in a parallel operation of inverters? How many of you have dealt with inverters? कोई नहीं? None. No, nobody with inverters? Nobody with renewable energy? नहीं. Okay. So, how should I put it? Okay. See, there is one solution, or this is how things operate. Okay, let's go back to the basics. We almost never know the demand, or do we know the demand? वो the basic question है, do we know the demand? हमको demand मालूम होती है. Do I know the demand? अभी 3:45 बजे मेरे को मालूम होगी क्या डिमांड है? Okay. So यहाँ suggestion है कि load forecast will give us the demand at 3:45 बजे. Is there anybody has to make a comment on that?
We may predict, but not fixed.
It will never be what it is predicted, right? It will never be what it is predicted. So how does the system run? How do we decide the generation? अब ये पॉइंट भगवान का नाम लेकर मत भूलना यार, ये पॉइंट मत भूलना।
Initially is done on the basis of maximum demand.
Yes.
And keeping on view the maximum demand, whole things are.
Yeah, chalo, if you say it will be 400 megawatt, we plan for 500 megawatt, right? But planning does, we have to deliver that power 410 megawatt it comes. So how does it deliver exactly 410? It has got capacity for 500. So the demand is never what you have predicted. It cannot be. It will always be different than that. But yet the system is running and providing exactly what you demand. Not less, not more. Is it fascinating or not? उसमें होता है यार, ये कैसे चल रहा है सब इतना बड़ा सिस्टम। जब तक वो नहीं होगा अंदर से कि कैसे चल रहा है, तब तक मजा नहीं आएगा। It can never match. So how is it being provided? Don't forget this one. सब भूल जाना, पर ये मत भूलना. How is that happening? We predict 400 and we end up with a load of 410 megawatts. And we deliver exactly 410 megawatts, not 1 watt less or more. We have to deliver exactly what is demanded. We can't deliver 1 watt less or 1 watt more. Is that making sense? वो तो नहीं भूल जाओगे यार अब, वो तो नहीं भूलोगे. Then tell me how is it done? सब भूल जाना पर ये मत भूलना. उसके बिगर पावर सिस्टम कुछ है ही नहीं.
Increasing the excitation to generate more power.
But how do we know?
The sensors are there.
क्या सेंसस कर रहे हैं?
Power sensors. The frequency.
या हाँ बोले अब हाँ. Now tell me how it is done. Yeah, somebody said something. Yes. We can manage, correct, manage the frequency. पर वो तो demand frequency तो फिर पता पड़ेगी. But demand has been met, right? You are right, 100% right. That we monitor the frequency, but the demand has been met. Has been met? How has it been met? यार इतना मुश्किल तो नहीं है. आपने in the last 5 days you have answered this question 50 times, not एक दो 50 बार आपने इसका जवाब दिया.
Load will draw the power from wherever it is available.
And where is it available from? नहीं, उस जनरेटर ग्रिड थोड़ी जनरेट करेगा. आपने ही जवाब दिया था सुबह और आप अभी
मैं भूल नहीं गया वो. I doesn't seem to be so simple question.
अरे आपने ही सुबह जवाब दिया.
Sir,
Kinetic energy of the rotating devices. ये मत भूलना भाई. मतलब this should be a constant matter of amazement that such a complex system runs so smoothly. Is that correct? Kinetic energy of the generator either absorbs or supplies the difference between this. This 10 megawatt will be supplied and that will slow down the generator. And as madam you said, that frequency will be monitored, so somebody will pump in more power in the generator to bring it up to again 50 hertz, and so the life goes on. Okay, so if the demand is if we are generating 400, demand is 410, it can be met. If the demand becomes 500, it becomes a stability issue, because the generators may not have so much kinetic energy and the mechanical systems may not be able to react so fast, but this is all secondary issues. Now, When there are no synchronous machines, how would you do the job? हमारे पास synchronous machine नहीं है, तो कैसे ये काम होगा? Yes. So how would the inverter know it has to act? क्या फीडबैक लोगे आप? Frequency and voltage both you take as a feedback. So here we saw that there was a time before we reacted, because you can't react instantly. The power has been, demand is there. So who will be supplying that 10 megawatt? Who will supply the 10 megawatt in between? Problem clear है? कौन देगा वो 10 मेगावाट? कहां से लाओगे आप? Pardon?
So then in that case, we need to have a reserve capacity in terms of storages. Or we can integrate some hybrid system.
Hybrid means you mean
Means combination of different energy sources.
different energy.
Solar, wind, kind of.
Okay, so now the story is this. You need some storage. So if you have got a battery, the battery will provide that. But you have to understand the whole dynamics of it. Now the battery is providing, and you don't want battery to be providing power continuously, right? So what will you do to take the power off the battery? Yeah, no, battery is providing the power. So you want power to come from some other sources, right? To take the battery off. So how would you tell the other sources to provide a different amount of power? See, this is all done automatically. No, see, you are right, but we have got a power system operating, all automatic controllers there, and when the battery power changes, we want the other inverters to chip in and relieve the battery of what it is doing. So how would we let the other people know that this needs to be done? Problem समझ आ गया?
Normal condition, battery is not delivering anymore.
Yes.
Now, when the power demand increases, that increased demand will be supplied from the battery, hence it will start discharging.
Yeah?
Cannot
Correct.
we take this as a reference?
अरे वो तो सामने वाला तो वहां बैठा है, यहाँ थोड़ी बैठा है. That guy is sitting 2 kilometers away. You have to tell that person to increase the power so the battery does not discharge. Is the problem clear? So we have to communicate to there are many ways to do it. Okay, so that is what I am telling. The reason I bring this problem to you is that now people are investigating. So these are the research problems, these are the problems you can think about, that how, when this happens, how do we communicate to everybody else that power is needed? So how did others know? In the conventional system, how did the generators know that they had to supply extra power? How did the generators know that they have to supply extra power?
The speed drops due to
Correct. So they had a signal built into them,
yes,
right?
that is sense and that is fed back to the
controller, governor and all that, right? So they had a built-in thing in them that was telling them to change their input power. Now, does an inverter have anything like that? It does not have anything built into it. So you have to communicate to the inverter that look, you need to change the power. And how do you communicate? There are many ways. One of the simple ways is the battery inverter changes its frequency. The same way the frequency was changed, that there it was natural, the battery inverter injects a change in frequency proportional to how much power it is discharging. So it is pre-decided that if it is discharging 100 megawatts, it will change the frequency by certain amount. If it is discharging 10 megawatts, it will change the frequency. And that change in frequency is picked up by other generators. That change in frequency is picked up by other inverters, and then they adjust accordingly. Is that process clear?
Sir,
Yes?
but if extra energy is already supplied from the battery, why inverter will get loaded? Because inverter is supplying.
Very good, very good. Anybody can answer that? Do you want battery to be continuously supplying energy? No. So we want battery as a kinetic energy thing. Same way in the generator. Its kinetic energy is supplying the difference. But you don't want it to be doing that. So you pump in more mechanical power. But that signal is already available to you as your generator speed. But here that signal is not available. How is battery going to tell that person? Clear problem? So battery, what it does is it increases the frequency. Right? It increases or decreases, whatever it is, proportional to how much power it is charging or discharging. The other inverters pick up that frequency. And by a pre-agreed scheme, those inverters change their output power so that the battery again goes back to sleep. Is that clear? And to do that, there is a device called right? There is a device called phase lock loop which picks up the change frequency, and based on that they change the output power of the inverters. Now, Srinivas, slides, or my area, that file explorer. File explorer? नहीं, फाइल एक्सप्लोरर है ना, डे 5 का नहीं है फाइल एक्सप्लोरर. Okay, that's all right. Oh, you got that hosting capacity thing. Okay. अभी आप रखे मैं. Well, till the chief guest comes or whatever, we will do that. This is a very sophisticated system. What is this? This file explorer. Yes. Yeah, so I'll come back to it. Just give me file explorer now. Okay. Okay, that's all right. Leave it there. So you see 3 files here. So don't worry about that. So one is exercise PLL. So what I have done is I have created lot of material for this course. And so these Simulink files, that exercise PLL, maybe double click if it opens. I don't know how long it takes. खुल जाएगा जल्दी. Because we are doing lot of research in the control of this PLL. See, this PLL picks up the change in the frequency. So it is, you would understand that the operation of PLL is very critical to the operation of power system. Can I get you to consider that? Would you consider that the operation of the governor of the synchronous machine is critical to power system operation? Similarly, PLL, the operation of PLL is very critical to the operation of an inverter. It's very critical. Now, there is a difficulty there. PLL happens to be, sir, I will stop whenever your guests come. Okay. PLL happens to be a very complicated device. But it takes a while. I mean, Simulink takes a while, it doesn't matter. Okay. Okay, we can go to the Explorer. Dusra? Yeah. So these are all the experiments you have done. Okay. So this block is what you have got in Simulink. Okay, this block is what you have got in Simulink. Now, all these blocks are non-linear blocks. See, if maybe you don't have experience with that, but the governor in a synchronous generator is a linear controller, right? It's a simple controller. Not with much complications, but this one here is quite a complicated control system, right? So you have got the files now. Srinivasji will send it to you. So all these transformations are necessary, and there is some theory involved why we do that, but that's a different story. But the important message to take with you is that just the way the governor, the inertia of the synchronous generator and all that keep this system working stably, it is again, as you said, there should be some storage in the system, there will be storage, and similarly we need to change the output powers of the inverters. So there is no inherent mechanism how inverters will know that they have to change their output power the same way as synchronous generators will know, right? Synchronous generators can just monitor their speed and they will know whether they have to change their power or not. But there is no inherent way for inverters to know that they have to change their output power. And to do that, there are many methods, not one, and people are continuously working. That's a huge research area, as you can imagine how important it is. It's a very important area, and people are working. One of the ways is to change the system frequency and use that system frequency as a communication signal rather than use a phone or something like that, because there is no human being sitting at the end there. It's all automatic control. So you have to send signals which can be interpreted by controllers and act accordingly. So one of the ways is to change, so this all is available to you in it's a working script, so you can run it. So this is a working script available to you. It is taken a lot of effort to create this script with many elements and all that. So let's see when it runs, we can see the plots and all that. Yeah, double click. Yeah, so all these plots are there, and there are some notes in there, so you can figure out what these. So here you can see there is a change in power quality, in the sense change in voltage. So these are designed so that what happens. So this PLL is working. Let's say this PLL is working. There is a drop in the voltage. There is an unbalance in the system. So there are many different conditions under which we need to monitor and make sure that PLL continues to read the correct frequency. Okay, so there are many conditions. It so happens that the synchronous machine is very, very robust. No matter what happens, the speed of the synchronous machine is directly related to the difference in input and output power. It does not matter. So it's very, very robust. In the case of PLL, it is not robust at all. It's a very difficult job to design controllers for PLL which will work in many different situations. So that's the research we are doing. We are designing different PLL controllers to work in abnormal conditions. Abnormal conditions mean short circuit, voltage imbalance, harmonics, and that's what it is. So this thing is with you. Okay. Okay, so this is all very nice thing. There are notes here somewhere. Did you see notes? Okay. Oh yeah, I think you go there, subsystem, inverter, yeah. Yeah, there are notes there. So you can read the notes, and it is there to help you simulate it yourself and test, and then you can change things. You can change your PID. So those of you who are working in PID controller design, they can change your constants and see how the performance changes. So there is a lot of learning material here. And in other scripts, what you have got. Maybe I am heavily prejudiced, but I can't learn things unless I know things well. So maybe it depends on individuals. It's totally different. But the things I've been talking about in the last 5 days are so essential to do anything with renewable energy. We have done very, very simple things. We have not done very complicated things. But all those things are important. So now we can go to the other one. If you have got time, we'll show the other one, the other computer. Okay, so now we'll see the hosting capacity script. So in this hosting capacity thing, I'll point out to you our research contribution, right? That this is our research contribution, which is different from all other hosting capacity methods. So hosting capacity, as we discussed yesterday, I think maybe not at great length, but enough length, that hosting capacity is to work out how much PV can be added now. Given the load conditions, given the solar condition, given this, given that, if we can work out how much PV can be integrated in the system, that is of great value. Why is that of great value? Nagpur here, if I say 100 megawatts of PV can be integrated now. Why can't all the available PV be integrated? Is there a limit to it, or any amount of PV we can integrate? If there is PV being generated here, within? Very good. So how do we design system? How do we decide system limits? Yes. Yes. Correct. Okay. So so yesterday we looked at current and all that. So the currents are indirectly given by. Currents are given by what is the fundamental quantity which gives everything else? Current is, once you know the node voltages, you know the currents, right? So node voltages is the thing which decides how much we can integrate, right? Is that right? Okay. So if I have got a machine learning algorithm, I feed all the node voltages to the algorithm and it tells me what is the capacity, right? Today we have been doing neural networks, right? So you feed something in and we get outside a number. So you've got a neural network. Okay? We feed that to it. When I say e to the power j, we are feeding two things, one number, one voltage, magnitude, and one angle. Right? So we feed that in, the output we get is hosting capacity. So that's a very big improvement on what is done. So what, you remember load flow, right? Sabko yaad hai load flow? So load flow is what gives node voltages, right? Load flow gives node voltages. So normally what we do is we run a few hundred or thousand load flows to decide that none of those hosting capacity scenarios violates these rules. What you said, there are certain rules about voltages, so we know that they should not violate these rules, right? So that is a very laborious process, that is a very time consuming process. So can we train? Good, thanks. So can we train that neural network to do this thing? I provide a voltage and angles at nodes and it tells me what is the hosting capacity. And that's all right. People have trained neural networks like that. And it's a big saving, because if you are operating a company or if you are a chief of the power systems in Nagpur, and just by that you work out, then you can dynamic. So if you have to do 1,000 load flows to work out the hosting capacity, can it be done in real time? Realistically, no. It takes a long time. But if you do neural network, can it be done? You have trained the neural network already. Once you train the neural network, how long does it take? I give the voltage inputs here and to get the hosting capacity. How long will this process take? How long will the process take? Fraction of a second. It's all addition and multiplications. Cut, it will be out. So if I have a trained neural network to do that, it will be a great help to people who operate the network. So what our contribution was, that instead of taking all the points, and this is a very, very good technique, there is something called pilot points. Pilot points are specially chosen points in a network which give more information. There are many points in the network where the sensitivity of the voltages and all is so low that no matter what happens in the network, things don't change there. So pilot points are special points in a network which reflect the change in the network condition, which are very sensitive to changes in the network condition. Right? So our contribution in this thing is to use pilot points and provide those pilot points here instead of the, so pilot points are around 5% of the network nodes. It can be around 2%, 3%, 5%, that's an enormous saving in the data you need. Suppose you are doing an online monitoring of the data, you need to monitor only a very small number of nodes. You need to monitor only a small number of nodes, get their voltages, and then feed it to the neural network, and you get hosting capacity. So this is what is done using. So this is all running in here. So what I'll suggest is, those of you are interested, so this script is running, Sai has got his working here, all those things are there, so you can also, all the files here, what are these files? They are training data. Training data means, so some of this data, so what should training data have? What should the training data have? Node voltages and, very good. Shall we run it cell by cell? We can run it, right? Oh. Ah. Okay. It has output, I guess. Final, this बीच में नहीं करेगा वो. There was output in between here. Okay. कोई बात नहीं. Okay. So, what is it that information you need? You need voltage and magnitudes and angle. What else information you need to train a neural network? Pardon? Target points, you need the true values. So the training data, so what needs to be done is, you take 1,000 cases, 5,000 cases, where you work out the hosting capacity beforehand, use that to train the data. So all these files here, so all the files here, wherever they are, yeah, these files, they contain the training data. So training data is already there for you. Test data is already there for you. So if you run, you will see, and then you can change, tweak many things. And if you want to do that, if you know of a network, so the data format is provided to you, you can generate data, you put it in that format, and you can use this script as it is to calculate the hosting capacity. So this is a very useful tool if you are into hosting capacity business. This is a very good tool to get started. And I'm not saying that you get limited to that, but this will be a good starting point. And the slides are there, the paper is there. I think the material you get, the slides are there, which will explain all these things. So what you need to do. Okay, and the papers are referred to, where they will tell you about the pilot points, how to calculate pilot points and all that. I mean, hard work has to be done. You can't achieve anything without hard work. But the very useful material is provided to you. I mean, you don't have to struggle to get started. So my whole point in this presentation was to provide lot of material to you to get started. And the type of things I have talked about, I mean, I am very, very sorry, but I really can't think. आप मेरे को 1000 बार कहोगे कि you do something different, I can't do it. Because what I said to you, I don't think that you can live without that. That's my conviction. आप मेरे को 1000 बार बोलोगे तो वो it won't sink in my head. These all the things we did in the last 5 days are extremely essential background for this, for getting into a serious study, serious research in this area, right? And what we discussed so far are sort of the way you should look at things, the way you should analyze things. Okay, so this is, so we have got hosting capacity. The reinforcement learning scripts you have got, they are also very powerful scripts. I mean, powerful scripts in the sense that whatever Allah did for research is totally, he had to spend lot of time to reduce the problem to a level where we can enter this reinforcement learning to simplify the problem and yet get results which show reinforcement learning. So you've got two scripts, very powerful, three scripts for reinforcement learning, one hosting capacity and one PLL control. So you have got lot of material for experimenting further, and I think if you tinker around a little bit, like Asai and all got it working, so you also, if you tinker a little bit, you can get it working. And what is the advantage of Python is, you can copy that code and put it in ChatGPT or Copilot or something, and they will explain to you in great detail what every command does. You only need to do that, you copy it, put it in ChatGPT or Copilot, and they will explain line by line what the command does. So what I have sort of tried to do is get you a starting point, which is the hardest thing in this business. And this is a good starting point because we have verified the utility of all this research and all this work, right? It is quite useful. It is at a simple level where people who are starting can get in, and it has got enough depth in it so that if you want to do research, you can continue from there. You can modify the scripts, you can modify the controller. I showed Simulink controller. You can modify it, you can modify gains, you can stick in your own other controller and see how it performs, etc., etc. So whatever wasted time or utilized time, who will know? But whatever it is, I try to do my best. Next time if I do, I'll do bit better in many ways, but the way I covered this time, I don't think that I can cover different. Maybe some things might be different, but not a lot. So if yesterday Professor Bhatt, I don't know how many of you know Professor Bhatt, we had dinner together. So he told of things. Somebody is waiting outside, is it? No? Okay. Okay. So he said that, oh well, these are the things you never read in a book. He was just telling during his student days and all that, how he found out some things, and he was so delighted to find them out. And he said that you never read them in books unless somebody tells this to you. So what I have told you over last 5 days, many of those things you will never see in a book. They are never in a book because I should say it differently. It is very hard for the students to read a book and see that it is something important. Because in a book, everything has got uniform importance. An author has taken great trouble to put material for you which the author thinks is important, right? And they have got a line of thinking, but some of the things are hard to get unless somebody tells it to you. That's how human mind works. It is never, it is very hard. So all these things I have picked up because I have got long experience in this field, and it is how things work. And when you do research, you want to make sure, or you have to make sure that you understand it right. Otherwise, you can't do anything. So as a result of that, I have tried to tell you things, many things, which you will not find in the books. And according to me, they are extremely essential. I can't say extremely essential. They are concepts without which you can't live. Okay, that's my understanding. Other people might have other ideas. Thank you very much.
సైడ్ అవుతుంది సార్ ఒక్క నిమిషం అందులో ఇది అది ప్లే చేస్తారు ఫస్ట్ సార్ పీపీటీ
You can send all the 5-day slides to everybody.
yes sir thank you very much for sharing అవి ఒక స్ట్రీమింగ్ ఆపేయాలి
సార్ కెమెరా యాంగిల్ ఏం చేస్తున్నావు
లైట్ షో రెడీ
సైడ్ షో రెడీ చేసి
దాన్ని లైవ్ స్ట్రీమింగ్ మంచిగా
ఇది కెమెరా యాంగిల్ బోర్డు కెమెరా యాంగిల్ దించు
है ना
Good afternoon, everyone. Respected chief guest, esteemed speakers, faculty members, and dear participants. I, Payal Jangilwar, on behalf of Electrical Department, extend a warm welcome to you all to the valedictory session of GAN course on AI-based methods for renewable energy integration for smart grid and electric vehicles. We are honored to have foreign faculty Professor Himanshu Pota sir, Head of the Department Professor B.S. Umre sir, Professor Varsha ma'am, course coordinators Professor P.S. Kulkarni sir and Dr. M.M. Lokhande sir with us. And I request all dignitaries to take their respective seats on stage. Please sir, have a seat. Over the past few days, we have had the privilege of learning from distinguished speaker, engaging in meaningful discussions and gaining valuable insights into this course. This event has truly been a great platform for knowledge sharing and professional growth. As we gather here to bring this program to a close, let us carry forward the knowledge and experience we have gained and continue to explore, innovative and excel in our respective fields. I now kindly request Professor P.S. Kulkarni sir to present a brief report on course activities and outcomes. Please, sir.
Thank you, Payal. Dignitaries on the dais, Professor Himanshu Pota, Professor B.S. Umbre, Professor Varsha Shah, Coordinator Makran Lokhande, all participants. So, it gives me immense pleasure to present in front of you the report of this 5 days GAN course on AI-based methods for renewable energy integration for smart grid and electric vehicles, which was organized during 30th June to 4th July by the Department of Electrical Engineering in this hall. On day 1, after the inaugural program, foreign faculty Professor Himanshu Pota covered the essential ideas of feedback, signal to noise ratio, and basics of load flow. On day 2, he emphasized on the frequency response in the closed loop. Later on, Dr. Makran Lokhande covered unipolar and bipolar PWM techniques, three-phase VSI, non-isolated topologies of inverter, leakage current mitigation, etc. Later on, Professor Pota covered feedback controller design and basics of transistor. On day 3, Professor Himanshu Pota taught the topic of machine learning powered AI, covering Hebb's learning rule, Widrow-Hoff rule, steepest descent method. Later on, he explained the significance of hosting capacity. Today also, he shared the scripts with the theory of hosting capacity in PV and EV. In the afternoon, I covered the important steps in the design of grid-connected PV system along with tutorial. This was followed by a laboratory session by Dr. Lokhande on unipolar and bipolar PWM techniques and leakage current simulation. On day 4, Professor Pota covered dynamic programming method with step-by-step approach, DC-DC converter and ANN. In the afternoon, Professor A.B. Andari, HOD Mechanical Engineering, VNIT, presented the work on vibration analysis of PV panels installed near Nagpur Metro. Later on, Professor Makarand Balla explained the techniques to identify faults in solar PV modules along with the demo. Later on, the participant enjoyed a visit to Center for E-Mobility, VNIT. On day 5, that is today, Professor Sandeep Anand from Electrical Department, IIT Mumbai, explained medium voltage SIC inverter for direct grid connection of PV and EV. Later on, Professor Himanshu Pota discussed the instability issue in power system, parallel operation of inverters, and in the afternoon session, he discussed the concept of PLL and also presented the Simulink and Python files. Professor Varsha Shah Madam conducted an overview of energy storage technologies for charging stations, impacts of EV charging, positive and negative impacts of EV charging on grid, etc. This GAN program offered valuable insights to the participants and opened several opportunities for further research. I hope all the participants will continue this work in future and will be in touch with us. Thank you very much.
Thank you, sir, for this comprehensive summary. I now kindly invite Professor B.S. Umre, sir, head of the department, to share his thoughts about this course.
On the dais, Pota sir, Shah madam, my colleague, Lokhande sir and Kulkarni sir, and dear participants. Thank you, sir, for your coming over here and staying here for a long period and giving the knowledge to the participants. I hope you have got some innovative idea from this GAN course. You flourish this idea in your research and do the research, publish the paper. This interaction and networking with this sir will continue further. As per the yesterday we have met with the director and director emphasis on this continuation of this education with the Pota sir. So in future also we will have some lecture. So wish you all the best. Thank you.
Thank Thank you so much, sir, for your thoughtful words and valuable perspective. I now kindly invite Professor Varsha ma'am to share her perspective about this course. Please, ma'am.
Dignitary on the dais and all participants and faculty members. Let me first convey my thanks to the coordinators who has called me and do some presentation to the audience or to the participant. And I'm sure, and another things which I have observed with the Professor Pota sir, that he is very energetic, isn't it? And continuously 5 days, he had delivered lots of stuff related with your AI application in power system with the integration of EV and renewable energy. So I hope that all of you have learned a lot and that might be very much useful in your future life. Wish you all the best. Thank you so much.
Thank you so much, ma'am, for sharing your views. I now kindly invite Professor Himanshu Pota sir to share his experience in this course.
Thank you very much. कुलकर्णी सर, उमरे सर, वर्षा मैम, लोखंडे साहब. अब मैंने जो 5 दिन में नहीं कहा वो 5 मिनट में क्या कहूँगा. एटलीस्ट मेरे को जो गले में तकलीफ है वो अब दूर हो जाएगी. अब मैं जो अब आप लोग समझे नहीं समझे, आई रियली डोंट नो, बट द ओनली purpose, one purpose I have in mind when I am teaching as a teacher, if you like, is to tell you you are more capable than you think. आप जो जवाब दे रहे थे, नहीं दे रहे थे, हिचक हिचक के दे रहे, that was not an opportunity to humiliate you or to feel bad, but to get the best out of you. If you did reply, if you found that your reply was right, your confidence will go up. If you gave a wrong reply, it does not matter. 1000 बार हम गलती करते हैं दिन में, but at least you will not repeat that mistake later. एक गलती कम हुई जिंदगी में. I heard a lecture from a Nobel Prize winner, and he said, what is the definition of an expert? कि जिसने जितनी गलतियां हो सकती हैं कर ली हैं. अब कोई गलती करने को नहीं रही है. Right? So that's the definition of an expert. So if you give a wrong answer, it does not matter. If you give a right answer, and believe me, you all are much more competent than you think yourself. It's only a question of application in this day and age where such fantastic tools are available for you to learn. I mean, sky is the limit of how much tools are there to learn. You've got all simulation tools, everything. When you get a question, you can get a very quick answer using simulation, doing some studies. So with the tools available, it's only a question of you going down all the way to the basics, not being satisfied with doing superficial analysis. And you can do it. I will repeat, that's my only purpose for the last 5 days, to give you maybe the way I teach is not the best way to tell you that you are more competent, but that's what I have been trying to do. So please take that message from my side, which may not be obvious, which you do not think that was what I was doing, but that is what I am doing. Think of it, our interaction, whatever we did, think through the material we covered, and that's essential for your life, professional life. There is nothing what we did in the last 5 days you can ignore for your professional life. Everything is essential. And having said that, I am extremely thankful for your hospitality. आप लोग मेरे jokes पे हंसे भी. That itself is a great kindness. अगर आप नहीं हंसते तो मेरे को बहुत दुख होता. Our daughter says, Papa, your jokes are on. क्योंकि उनको चोट लगती है ना जब मैं जोक करता हूँ तो वो सहन नहीं कर सकते. So our daughter says that, so thank you very much for that. लोखंडे जी, Professor Kulkarni, you have been extremely kind with your hospitality, taking care of me right from the time I came to India, or even before I came to India, taking care of everything. So thank you all. और मैं तो मराठी वगैरह मजाक करता हूँ हमेशा, पर मेरे लिए I grew up in Rajasthan, then in Gujarat. मेरे को people ask me, if there is a Gujarati, I have no affinity. If there is a Rajasthani, I have no affinity. But I have affinity only towards Indians. कोई Indian है तो मेरे को regional affinity I don't have at all. So I don't know, growing up in Rajasthan, that makes a difference or not, I don't know. But मेरे को regional affinity किसी से नहीं है. I've got affinity only with India. So thank you all very much for being so kind to me. Thanks.
Thank you, sir, for your inspiring words. So as we all know, no program is complete without the voice of those it meant for. I now kindly request participants to share their experience and give feedback to us. From participants, if anyone wants to come here and share their feedback with us. Welcome, sir. Sir, your name?
Introduce yourself.
Okay.
नमस्कार. एंड होतोय कार्यक्रम. मराठीत चालेल सर? Okay. So better to use a language which is commercially available and commercially acceptable, English. मराठी आणि हिंदीचा तसाही वाद सुरू आहे सध्या. So we are at the end of this GN course for a week. The idea of joining this course or attending this course to get something different than what we studied in books and what we learn from the textbooks and from the other sources. I was never been to the GN course before attending this course. So it was completely a different experience, and especially thanks to the Pota sir. You all must be favoring my opinion that, sir, kindly bless us to have the same energy for us during our times at your age. So please bless us so that. नहीं definitely नहीं sir. You are one amongst us and we are all amongst you. So it was wonderful sessions by Pota sir, and especially the way he taught us the topics and covered the topics during these 5 days. Amazing, sir. Means to the basics and to the level of analytical portions also, and the way of interaction with the participant, that was awesome. So thank you very much, VNIT Department of Electrical Engineering, and special thanks to Dr. Kulkarni sir, Dr. Lokhande sir for taking the initiative in organizing this wonderful course of Gyan. Thank you, Dr. Umbre sir, for hosting this wonderful program. I once again congratulate all the coordinators, and special thanks to the volunteers who are here, the student participants and student volunteers, for taking tremendous efforts in execution of the program. This is somewhat missing part in other institutions. Students do not take part the way you have taken in this execution of the program. Thank you very much, sir. Thank you all.
Thank you, sir, for your valuable feedback. Any other participants who wants to come here? From female participants, please come here. Please come, ma'am.
Only positive. Tell us some negative also.
Good evening to all the dignitaries. हिंदी चालेल म्हणाले. नमस्कार. सबसे पहले तो जब ये कोर्स का नोटिफिकेशन मेरे चीफ इंजीनियर जो है कोराडी थर्मल पावर स्टेशन के, उन्होंने जब ग्रुप में डाला तो मुझे ऐसा लगा कि क्या है, तो एक्साइटमेंट में मैंने रजिस्ट्रेशन भी कर दिया और उनसे कंफर्मेशन भी ले लिया. तो बोले उनका VNIT के लिए बहुत ख़ास अफेक्शन है और मेरा भी. सो दोनों का रीज़न एक ही था. तो बोले मैम आप जाओ. अब मैं अभी थर्मल पावर स्टेशन के ट्रेनिंग सेंटर में काम करती हूँ। तो सबसे पहले तो मुझे जो इनका प्रीमाइसेस बहुत ही अच्छा लगा, जो स्मार्ट क्लासरूम है, ये बहुत ही अच्छी बात लगी। सर ने बोला पॉजिटिव निगेटिव दोनों बताना, तो मैं अपॉर्चुनिटी इनकैच करती हूँ। और रहा सवाल कोर्स का, तो कोर्स जो था वो 5 दिन के जो भी सेशंस कंडक्ट हुए, उसमें सारा जो भी करंट सिनेरियो है, फ्यूचर प्रोस्पेक्टिव्स जो है एनर्जी सेक्टर के, विथ रिन्यूएबल विथ आरई कवर करने की सभी फैकल्टीज़ ने कोशिश करी। बीइंग अ पावर सेक्टर एम्प्लॉय, हमारा मेन कंसर्न हमेशा ग्रिड रहता है। स्मार्ट ग्रिड, ये वर्ड सुन के मुझे और मेरी जिज्ञासा जागी थी कि स्मार्ट ग्रिड क्या। तो उसका जो एनालिटिकल जो पोर्शंस जो है, एनालिटिकल चैप्टर्स जो है, वो भी फैकल्टीज़ ने कवर करने की बहुत अच्छे से कोशिश करी। और जो अभी सर ने कहा कि सर प्लीज़ ब्लेस अस विथ योर एनर्जी, ये उम्र में ये एनर्जी। लेकिन मेरा ये ऑब्जर्वेशन है कि जो भी इतने इंटेलेक्चुअल्स लोग रहते हैं हायर पोस्ट पे, वो शायद उनकी एनर्जी बहुत ही हाई रहती है, क्योंकि हमारे जो भी चीफ इंजीनियर्स है, एग्जीक्यूटिव डायरेक्टर्स है, सभी खैर पोटा सर के ही मतलब इसी में आते हैं। तो उनका भी जब हम लोग वेलकम करते हैं, वो जब इंस्टीट्यूट में आते हैं, द एनर्जी लेवल दे ब्रिंग टू अस इज ट्रिमेंडस। और जो गाइडेंस उनका होता है वो दैट वाज वेरी, मतलब वो बहुत ही हेल्पफुल रहता है। सो मैं VNIT को बहुत थैंक्स देना चाहूँगी कि इतना अच्छा कोर्स उन्होंने ऑर्गेनाइज किया और अपॉर्चुनिटी दी। और ऐसा कभी नहीं था कि सेशन बहुत ही मोनोटोनस थे, और सबसे ज़्यादा इंटरेक्शन पोटा सर के लेक्चर में हुआ। और सर बोलते भी थे कि नहीं मैं डांट देता हूँ, लेकिन इसका मतलब ये नहीं कि ऐसा है, लेकिन ठीक है मज़ा आ रही थी। और मेरे लिए ये था कि ये जो यहाँ पे जितने भी लोग बैठे हैं वो सारे कोई फैकल्टी मेंबर्स है, कोई PhD स्कॉलर है। मेरा तो BE करने के बाद सारा डेल्टा थीटा गैमा सब छूट गया क्योंकि हमारे इधर ये कुछ भी नहीं है ऐसा। सो मुझे ये मेरे लिए भी एक अपॉर्चुनिटी थी कि मैं वो पढ़ूँ, और मेरी बेटी ने बोला थोड़ा तो पढ़ तो इसीलिए मुझे और लगा कि नहीं, मुझे और पढ़ना चाहिए। और मैंने ये जो भी सेशंस होते थे ईमानदारी से मैं सुनती थी रात में सोते समय। तो ये मेरे लिए भी एक प्लस पॉइंट हुआ कि मैंने उतने क्यूरियोसिटी से और उतने पेशेंस से इसको खुद के लिए यूज़ किया। और मैं सभी कोऑर्डिनेटर्स का, लोखंडे सर, कुलकर्णी सर, उमरे सर, पोटा सर, शाह मैम, आज सुबह संदीप आनंद सर आए थे, उनका सेशन बहुत ही अच्छा लगा मुझे, बहुत ही मस्त सेशन था। सभी सेशंस के लिए सभी फैकल्टीज़ का, कोऑर्डिनेटर्स का धन्यवाद करती हूँ। और जो भी वॉलंटियर्स थे, सच में कमेंडेबल जॉब, उनके लिए तालियां बनती है। थैंक यू सर, थैंक यू सो मच, थैंक यू एवरीबडी। सर रहने देते हैं दुधात तो मिठाचा खडा कशाला सर असं म्हणतात, मराठीत म्हण आहे की सांगताना समोरच्याचे चांगले पॉईंट 4 चौघात सांगावे, जे निगेटिव्ह असतात ते एकट्याच सांगावे. तर आपण पर्सनल कॉन्व्हर्सेशनमध्ये ते कव्हर करू. सर असं निगेटिव्ह ॲज काही नव्हतं. थँक्यू सो मच.
Thank you, ma'am, for your valuable feedback. We appreciated your feedback. We will now proceed with the distribution of certificate. I request dignitaries on stage to kindly do the honors. I request Himanshu Pota sir to distribute the certificates. I will tell the name one by one. Mr. Manohar Nivrutti Kalunde. Sir, आप उससे हाँ ठीक है. सर स्टेज के नीचे सर हाँ. डॉक्टर कल्याण सुंदरम. मिस श्रद्धा सुके. यस सर. मिस्टर अमरदीप. डॉक्टर प्रफुल्ल. Mrs. Shweta, Shweta ma'am. Mr. Shravan Kumar, Miss Smita, Smita ma'am. Now I kindly request Varsha ma'am to distribute the certificate. Mr. Kunal, Marudra Shinde, Mr. Praful Singade, Miss Anaga, Dr. Praveen Pisal, Mr. Ashish Daikar, Mr. Ashish, Mr. Ketan Meshram, Mr. Shivam Rao, Mr. Sudhir, Miss Sonal Meshram, Dr. Snehal, Miss Prajakta Devtare. Now I request HOD sir to distribute the certificates. Please, sir. Mr. Satish. Miss Rashmi Singh. Mrs. Kanchan Gule. Mr. Tikam Bhardwaj. Mr. Rana. Mr. Rana Singh. Mr. Gajanan Adkine. Shubham Gupta. Srinivas. Vinay Kumar. Vinay Kumar. Sai Charan. Shruti. Murli Manohar. Jay Tembekar. Vedika. Mr. Priyanshu.
Miss Payal.
Now I kindly request Professor Umre sir, HOD of our department, to present a memento to Honorable Himanshu Pota sir. I request HOD sir to present a memento to Honorable Varsha, Professor Varsha ma'am. I kindly request Professor Kulkarni sir to present a memento to Honorable HOD sir.
ज्ञान तो आता जाता रहता है पर एक्चुअली बहुत इम्पोर्टेंट
Thank you, sir. I request HOD sir to present a memento to Ballal sir. I request HOD sir to present a memento to Professor Kulkarni sir. Thank you, sir. I request HOD sir to present a memento to Dr. Lokhande sir. Thank you, sir. Thank you all dignitaries for distributing the certificates. To conclude this session, I kindly invite Dr. Lokhande sir to deliver the vote of thanks.
So, good evening, all of you. So, we are coming to the end of the session, and Dr. Professor B.S. Umre sir, Professor Himanshu Pota sir, Kulkarni sir, Varsha madam, and all participants, colleagues here, Senior Professor, Dr. Ritesh Keshri sir, all our MTech PhD students, and all participants. So, it's a great satisfaction for us today. After all the 5 days what we have gone through, the various lectures that, so we all have come here with the different expectations maybe, but hope many of the expectations or some different expectation or whatever the expectation you have assumed, your efforts are aligned, may align in that direction, because it was very basic understanding that Professor Pota has given us, and it has done with all the fundamentals, all the science, mathematics. So his lectures reflected the science, mathematics, philosophy, and many more things. And he was behind us always to fulfill the activity. So that was really great, and really stand very different GAN program because of this. So I really thanks Professor Pota here that he has come here, and from initial point, from the submitting the course, he has helped a lot, and after getting the course approved, then also we have decided many things I had to mail him. He has to mail me. Then even from the brochure. So how to design the brochure? He was meticulously see the designing of the brochure should be perfect. That is also he has looked. So it was really, I think, working hard for this course. And even many of us don't know, in the airport we just pass the time by visiting the many shops. But he has done some exercise, and maybe the one part of the lecture was he has prepared in the lounge of the airport. So that was what he has took the effort. So I don't know. We have seen little effort. I know maybe he has done many efforts to design the content of this course, and really it was wonderful that he has learned many new things. Okay, it's not that only the actually he has started the fundamental, and it was really wonderful that he wanted to know us all the fundamentals behind the thing, science behind the thing, mathematics behind the thing, and approaching to the new concept of machine learning and neural networks and all. And really, I think it takes more effort to relate the new things and appreciate the thing, relate the thing, and use that things. So the person who is year of 67 plus can do the things. I think we should learn from that. We should learn the new things to implement, and not forgetting the basic concept. Okay, so he was always pointing from like this to this. Okay, so sometimes it is difficult to even bend at this age for us sometimes. But he was quickly very flexible. I don't know, he may be doing some meditation and all. Many times he bend and just raise quickly like an impulse. So it's really thank you for you, sir. And thanks for our director, Professor Premlal Patel, who also encouraged us to apply for this course and help us to conduct this course. Our head of the department, Professor Umbre sir, he was also happy in conducting the course, and always kind to us for anything that we required for this course, for any arrangement. So he was always ready. So thank you, sir, for all this thing. And thanks all the speakers that apart from the like Professor Balla sir, Makaran Balla sir. So it was really wonderful lecture and wonderful visit on the terrace. Wonderful discussion also. And Professor Andare sir. Professor Andare sir from mechanical department on the vibration. It's a very different topic, but really now the time is for interdisciplinary work. So it ignites the mind how to start, maybe we can involve in the interdisciplinary work. It's a very interesting topic. Then today's lecture, Professor Sandeep Anand. It was also very wonderful. Already you had told about that, no need to tell more. Professor Varsha madam, on last week only I called her that you should come here, and she wanted to come as attendance, but I asked her to take some lecture also, as we have the common PhD students in SVNIT Surat, and actually she only gave me the motivation for doing the research work in the electric vehicle. Otherwise I would not have touched the electric vehicle also. So thank you madam for coming here and joining us and delivering the lecture. So and thanks first of all our all volunteers. Okay, so please come here. Srinivas, Vinay, please come here. Sai, please come here. Shruti, Sai, Murli, Shubham, please come here. Jai. So please clap for them. So with a lot of energy and enthusiasm. So they were on the stage behind. Payal, please join them. I don't know who else I forgot. So really, it was the behind the stage and on the stage they have worked a lot, and we thought that we should conduct 5 more GAN courses with the help of them. Okay, we should somehow retain them. Vinay has cancelled his postpone his visit to the pilgrimage. He wanted to go some Tirupati. He postponed for this course and many things. And they are working since a month, really hard. And thank you for all of them. That because without them we could not have even done many of the things that was required for this course, essential for this course. Like live streaming, and they really learned it, and really it was appreciated that they should be what we can say. Kamlesh, they also help us a lot in conducting this course, and other faculty members, okay, and other staff of our department, our institute, like our network center, then security, they provide a battery operated vehicle, then guest house, they provide, I think no one has commented, maybe they are written, food must be delicious, your stay must be delicious, you have seen the campus, I think, so it was wonderful. And last but not least, some participants that have come, okay, for believe us and shown confidence on us that so the registration since a month some students have registered for this course when you have put the ad. So and active participation. It's not that they have just listened and then they just moved out of the classroom. So it was also really wonderful. Thanks for you, all the participants also. So thanks one and all. Keshri sir here is a GAN coordinator. So he's the only person that will conduct overall course coordination of the GAN courses. So he has also helped us a lot in this course. So thank you one and all. Thank you all.
Thank you, sir. So with that, we come to the end of this valedictory session. Thank you all of you once again for your active participation and your valuable contribution. Now we will proceed for a group photograph. I request all participants to. Sorry for the change. First we will proceed for national anthem, then group photograph. So please stand up for national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंग तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत माता की जय. Now we will take in front of the department. So now we will proceed for the group photograph.
Here only, on the back side we'll have a slide.
Sir.
आप सामने आइए, आप सामने